Alright, so let's start on Usubstitution. Here's example 1 here. It says recognizing the pattern. So what it's doing is it's saying, look, if you want to find the antiderivative of this, we also need the derivative of the inside, and that's 2x. So rather than quote-unquote recognizing the pattern, I'm going to show you the actual process for Usubstitution. So the process for Usubstitution is first is select u. So I'm going to let u be the inside of the function, whatever one is the higher power here. And so here I'm going to let u be x squared plus 1. So u is going to be x squared plus 1. Okay? Step 2 is you're going to differentiate u with respect to x, both sides. So take the derivative with respect to x of both sides. So on the left-hand side, we have du dx. And on the right-hand side, we'd have, well, the derivative of x squared plus 1 is simply 2x, right? Step 3 is going to be solve for dx. I'm going to write that down, solve for dx. So if I were to solve for dx, I would multiply both sides. Let me show you the math. I'll show you the math once. Really all it is cross multiplication. Okay, so I'm going to multiply both sides by dx, but I'm also going to divide both sides by 2x. So this is where you're really getting that cross multiplication idea. That's where cross multiplication comes from. So the dx's cancel on the left and the 2x's cancel on the right. And when I do that, I'd end up with dx equals du over 2x. Okay? So this is really, really important for us. Let me circle this part right here. No, let me highlight it actually. I'm going to highlight this part right here. Here's dx. And I'm going to highlight this part right here. Here's u. Okay? And so now the fourth step is to, give me 1 second. The fourth step is to rewrite the integrals in terms of u's and du's. So this would turn into the integral of, instead of x squared plus 1 quantity squared, that would be u squared. Then we have the 2x is still there, that's not part of anything, but then we substitute for dx as well. So not only are we substituting in for u, we're also substituting in for dx. So according to our blue highlighted area right here, dx would equal du over 2x. Notice what happens, the 2x's simplify, and you're left with the integral of u squared du. And that's what should always happen if you do your u substitutions properly, is you end up with an integral with only u's in it, and you're taking the integral with respect to u. So we're going to integrate this using the power rule, so that's step 5, is integrate using the power rule. So if we integrate using the power rule, the integral of u squared is u cubed over 3, or u 1/3 u cubed. And then of course it's plus c. We really don't need that till the end, but I'm going to write it because I remember it. Then you do step 6, which would be back substitute for u. So we got to remember, what was u? Well, u was x squared plus 1. So this is equal to x squared plus 1 quantity cubed all over 3 plus c. And that should be our final answer right there. X squared plus 1 quantity cubed over 3 plus c. Okay? What do we want to do? Let's check our answer. And by checking the answer, all we have to do is take the derivative of the answer. Again, I'm not going to take the derivative of the plus c part because we know the derivative of a constant is 0. So if I found the derivative of this, I'd use the power rule. Well, first of all, my constant multiple is 1/3. I'd drop the 3, keep the inside the same, so that's the x squared plus 1 to the power minus 1, so that'd be squared. But then I need to multiply times the derivative of the inside, and the derivative of x squared plus 1 is 2x. When I do that, the 1/3 and the 3 cancel, and I'd end up with x squared plus 1 quantity squared times 2x. I look at my original problem, that's exactly what it was. So I've checked my answer and I know I've done it correctly. Okay? So I just spent a lot of time on that problem to show you how it works, the process, the 6 different steps. Sometimes I might call it 4 steps, but that's what it is, breaking it out just like that. That's Usubstitution. You'll get really quick at it. You'll get, and it'll make it hopefully not so bad for you. So let's look at example 2 here. It says find the integral of 5e to the 5x. Again, the reason that we can't integrate this is because it's not just x, it's a 5x. So what do we do? Again, our first step, we're going to identify u. So I'm going to let u equal whatever the power is. In this case, it was 5x, right? Step 2 is I need to find the derivative with respect to x on both sides. So on the left-hand side, I'd have du dx. And on the right-hand side, the derivative of 5x is simply 5. I have to solve for dx. So all I do again is I'm just going to cross multiply. The dx is going to go over here. The 5 is going to go down there. So I'm just swapping those. So dx equals du over 5. Okay? And that's what I said was step 3. So step 1 is define u. Step 2 is differentiate. Step 3 is solve for dx. Now we're going to go ahead and go back to step 4. Again, step 4 is we have to substitute in for dx. So dx in this case is du over 5. And we also have to substitute in for u. U is 5x in this case. So what do we end up with? This would turn into the integral of 5e to the, instead of 5x, that'd be u. And then instead of dx, we'd have du over 5. Well, again, notice what happens. The 5 simplify, and we're left with the integral of e to the u du. Everything's in terms of u, so it looks great to me. So we go to step 5, which is actually integrate. Well, the integral of e to the u with respect to u would be e to the u plus c. And then step 6, which you can't forget, is we have to back substitute for that u value. So this would be e to the, well, u was 5x, so this would be e to the 5x plus c. So our answer should be e to the 5x plus c. How do we know? We can always check our answer. How do you check your answer? By finding the derivative of your answer, again, minus the plus c. The derivative of e to the 5x is copy-paste, but then you have to multiply it times the derivative of the inside, which would be 5e to the 5x, exactly as the original problem was, so we have the answer correct. Let's go on to the next one here. It's the integral of x times the quantity x squared plus 1 quantity squared. I can think of multiple ways of doing this problem. One way would be, in all honesty, just foiling it out, distributing everything out. That would be a lot more work, a lot more algebra. Let's see if we can do it using Usubstitution. Although expanding it out would work and I would accept it, let's go ahead and try Usubstitution. Alright, so let's begin. Step 1 again is going to be choosing u. It's the inside part. So let's let u equal the x squared plus 1 in this case. Step 2 would be differentiate both sides. So what we would have is du dx would equal, well, the derivative of x squared plus 1 is simply 2x. Step 3 would be solve for dx. Again, we're just going to cross multiply. So multiply both sides by dx, divide both sides by 2x, and that would give us dx would equal du over 2x. Okay, so that is what dx is, du over 2x. And then we also need to substitute in for u, which was x squared plus 1. So step 4 again is rewrite that integral. Sorry, give me a second. Step 4 is rewrite that integral. So the integral would look like the integral of x times, instead of x squared plus 1, that would be u squared. And then instead of dx, we would have du over 2x. So if we notice this time, the x is simplified, but the 2 does not. But that's okay because that's just a constant multiple. So we can pull that out in front. You just need to be really careful. You're not pulling the number 2 out in front. Remember, the 2's in the bottom. So you're actually pulling out a 1/2 is the constant multiple on this one. So this would be 1/2 times the integral of u squared du. Okay, so now we go on to step 5, which is actually integrate it. So this would be 1/2 times, well, the integral of u cubed would be 1/3, or sorry, u squared would be 1/3 u cubed, or u cubed over 3. I just wrote it like that so you could see the constant multiples. So this would be, what, 1/6 u cubed plus c. Okay, and then the final step that we need to do in this case is back substitute for u. So think about what was u. U in this case was x squared plus 1. So this would turn into 1/6, sorry, wrote the wrong number, times x squared plus 1 quantity cubed plus c. And that should be our final answer. Let me go ahead and write that in the blank. 1/6 times x squared plus 1 quantity cubed plus c, but we want to check our answer. We can always check our answer, and we always should check our answers with integration. So let's find the derivative with respect to x of 1/6 times x squared plus 1 quantity cubed. So constant multiple out in front is 1/6, drop the power, which is the 3. Inside stays the same, so that's x squared plus 1, power minus 1, so that'd be a 2. Then we need the derivative of the inside, don't forget the chain rule part of it. The derivative of x squared plus 1 is that 2x. When we simplify all of that, we would have a 3 times a 2x, which would be a 6x, divided by 6 would just be x, so we'd be left with x times x squared plus 1 quantity squared. Look at the original problem, they're exactly the same, so we know we have the right answer. So that's our process of U substitution. Again, it's the same 6 steps every single time. Identify U, take the derivative, solve for dx, substitute in U and dx, and simplify. You should get an integral in terms of U only. You should be able to integrate at that point, back substitute for U, and you're done. Okay? I know it seems like a lot of steps, but again, with practice, you're going to get very good at this.